Bismillahirrahmanirrahim. Assalamualaikum little kids. This is Shehroz Abdullah and now today we are going to discuss Introduction to Electronics. And today we will discuss two of the topics, Introduction to Electronics and then we will discuss logic gates. Okay. First of all, we understand what is electronics. Since from the start of the chapter on day 1 I have defined electronics. Electronics is the applied branch of physics which deals with the emission of electrons, its utilization, its application and the study of those devices through which electrons can be emitted, and the study of all those devices, the emission of electron, utilization, process, mechanism, all this comes under electronics. Okay. Now electronics can be broadly classified into two of the branches. Number one, analog electronics, and the second is digital electronics. Analog electronics is that branch of electronics which deals with analog quantities. Now, what are analog quantities? Analog quantities are those quantities which may remain fixed or may vary. For example, temperature, humidity, sensation, all these are what? These are analog quantities. So, these may remain fixed, these may remain changed. Okay, known as analog quantities. Now, we can also define analog quantities as those quantities which can be perceived, which can be sensed, which can be perceived, known as what? Analog quantities. Okay, coming back towards digital electronics. Digital electronics is that branch of electronics which deals with digital quantities. What are digital quantities? Those quantities which cannot be perceived. For example, 0 and 1. This deals with digital quantities. Like digital electronics is that branch of electronics which deals with only digital quantities. Now, what are digital quantities? Digital quantities are those quantities like 0 and 1 which cannot be perceived. Okay, this is in form of what? In form of digits. Okay. Now, let's discuss what is Boolean algebra. You know, Boolean algebra is basically the branch of mathematics which deals only with two quantities, that is 0 and 1. These quantities are called digital quantities. Now, over here, what does this 0 mean? What does this 1 means? 0 means off, OR, you can say low, and 1 means high, OR, we can say on. If the output of a circuit is 0, so we will say that the circuit is off. If the output of a circuit is 1, so we will say that the circuit is on. Okay. Now, coming back towards logic gates, you must have experienced that, you must have seen that calculator can perform addition, multiplication, subtraction and different functions. Even computers, even laptops and different digital devices have the ability to perform different logical operations. All these devices basically use what? Logic gates. Logic gates are the building block of the electronic circuit. And there are so many electronic devices in which different class of logic gates are used. Like logic gates, you can say these are the building blocks of what? Electronics. Okay. Now, what are logic gates? Logic gates are such type of electronic circuits which are operatable on logical operations. Now, what are logical operations? These operations can be addition, multiplication, any other it can be. We are having different classes or different types of logic gates, right? The first type of logic gate is AND gate. Okay, AND gate is that type of gate which performs the multiplication of two binary digits or binary digits multiplication. We use what? We use AND gate. So, okay, we can say that AND gate is that type of gate whose function is to multiply two binary digits. Okay, the symbol for AND gate is this. Okay, it takes two inputs over here like this. Look, A and B. These two are what? These two are inputs. Okay, and it gives you output. For example, it gives you output X, and that output will be in form of multiplication like A dot B. Okay, now this is what? This is AND gate. Okay, now what can be the truth table of this logic gate? Look, how can we write truth table of this? Okay, we can write that. Look, This is input and that is output. Okay. Now we are providing inputs in form of A and B. Look, this is A, this is B, and output is in form of C. But this will give you in multiplied form. Look, now we are having standard inputs like 0, 0, 0, 1, 1, 0, 1, 1. Okay, now look, what will be the operation on logic gates? Multiply 0 and 0, this will give you what? This will give you 0. Multiply 0 with 1, this will give you 0. Multiply 1 with 0, this will give you 0. Multiply 1 with 1, this will give you 1. Now we can define logic gate by 3 methods. Look. Now 3 more definitions can be done for logic gates. Look, we can say that electronic circuit or that logic gate whose output is 0 when both the inputs are 0. The logic gate whose output is 0 when both the inputs are 0, known as AND gate. This is the first definition. Now come to our second. That logic gate whose output is 1 when both the inputs are 1. Okay, this is second definition. That gate whose output is 1 when both the inputs are 1. Now we can also define it like this. Look. The gate whose outputs are 0 when any of the input is 0. Okay, you can observe the table. If any of the input is 0, then output definitely you are going to get 0 because 0 multiplied with anything will give you 0, right? So we can define it like this also. The logic gate whose outputs are 0 when any of the input is 0. So this is all about what? This is all about AND gate. Now coming towards different other types of it. The second is OR gate. Okay, let's discuss OR gate. Okay, second is OR gate. The gate which is used for the addition of binary digits known as AND gate. AND gate can be represented as like this. Okay. This is what? This is what? This is OR gate. OR gate is that type of gate which is used for the addition of binary digits. Now A and B we are providing inputs to it. Like this is what? This is input. We are discussing OR gate. OR gate is used for the addition of the binary digits. Now this is the symbol of OR gate. We are providing 2 inputs to it like A and B, and we are getting output like A plus B. Okay. Now how can we draw the truth table of it? Look. We can draw truth table of OR gate like this. These are what? These are inputs. These are what? These are outputs. Now we have provided 2 inputs like A and B, and we are getting output in form of added. Like we get the output in addition form. Okay. Now look. 0 0 0 1 1 0 1 1. These are what? These are inputs. Now, what output we are going to get? Now observe. 0 added with 0 will give you 0. 0 added with 1 will give you 1. 1 added with 0 will give you 1. 1 added with 1 will give you 1. This is not simple mathematics, okay? Over here 1 plus 1 will not give you 2. But basically this means when first input of the circuit is on, second input of the circuit is on, definitely the output that you are going to get will be on. Okay, so this means when both the inputs of the circuit is on, so the circuit will be also on. Okay, now we can define this by different ways. How can we define? Look, the gate whose output is 0 when both the inputs are 0. This is first definition. Coming towards second definition. The gate whose output is 1 when both the inputs are 1. This is second definition. Now coming towards third definition. The gate whose outputs are 1 when any of the input is 1. The gate whose outputs are 1 when any of the inputs is 1, known as what? OR gate. Now coming back towards NOT gate. This is now we are discussing the third gate, that is NOT gate. Okay. Third gate we are going to discuss, that is NOT gate. NOT gate is also known as inverter. Basic function of NOT gate is like whatever inputs you are providing to it, it will produce output exactly opposite of the given input. Like basic function of NOT gate is to produce output exactly opposite of the output given. Like whatever input you provided, definitely it is going to produce the output exactly opposite of it. Like how? Look, definition I have done. Now symbol of NOT gate is this. Look, this is what? This is NOT gate. It has a small circle at the end. Now if you provide A, definitely you are going to get output in form of X, but it will be A dash. A dash over here shows the opposite of the given input. For example, look. Now if we provide 0, its output will be what? Its output will be 1.